Question 7b is very similar to 7a, where we're supposed to write the polynomial. Given the zeros, so we have zeros of -4. So -4 is a 0, and we also have 2 minus 3i is a 0. Remember, complex are a little cowardly. They never come alone. They always come in couples. So this 2 minus 3i is accompanied with a 2 plus 3i. They are called complex conjugates, these two. So they never come alone. They always come together. What we want to do now is change all of our zeros into factors. And as I did in the previous slide or video, if you watched that, what we know is that our x-intercepts and our zeros are equal to -4. So when we want our factors, we set this equal to 0. So what we want to do is add the 4. So if we add the 4, we get our factors that are always going to be set equal to 0. So if I take the 0, which is 2 minus 3i, the 0, the root, the solution, the x-intercept, that's what our x is. We want to set that equal to 0 so we have our factor. So it's going to be x minus 2 equals to -3i. It's going to be x minus 2 plus 3i is equal to 0, and that is our factor. So if we apply the same strategy to our last one here, without going through all that, it's going to be a -2 minus 3i. So the other idea is, many people just said, just change it to their opposite. So if it's -4, make it an x plus 4. If it's a 2 minus 3i, then make it an x minus 2 plus 3i. Change both their sides to their opposite. And this will be an x minus 2 minus 3i. These are your factors, and you have to multiply them together. When I'm given this choice, I will typically take the two polynomials that have the complex number and multiply them together, and I'll take it times the x plus 4. So this x plus 4 is going to wait out here until I get it done with the distributive property on my last two polynomials. So we're going to distribute 3 times, so the x times x is an x squared. This x times a -2 is a -2x. This x times a -3i is a -3xi. I'm going to distribute through with the -2. -2 times x is a -2x, so I got another one of those. -2 times a -2 is a +4, and -2 times a -3i is a positive 6i. Then I want to distribute through with a 3i, so 3i times x is a +3xi, so plus 3xi, like terms underneath each other. If I take a 3i times a -2, that's a -6i. Those are like terms. And I'll take the positive 3i times a -3i, which would be a -9i squared. Okay, so I'm going to put that in a bracket. I'm going to collect the like terms that I can there, and then I'll end up multiplying by x plus 4. So we have an x squared, we have a minus 4x. The 3xi and the -3xi reduce. The plus 6i and the -6i reduce. And remember that I squared is equal to a -1, so this is really a +9 sitting here, so +9. And our +4 gives us +13. So I collected those terms together there. We have to distribute one more time, and this time we're going to distribute by our x plus 4. So an x times x squared is an x cubed. And x times -4x is -4x squared. And x times 13 is 13x. Then we'll distribute through with our +4. That will be a 4x squared. We'll have a -16x. And 4 times 13, +52. So when we collect all like terms, we'll have a trinomial or a polynomial. There's a third degree, so we got x cubed. Our squares will reduce. We'll have a -3x plus 52. This is our polynomial of least degree with integral coefficients. It needed to be a third degree polynomial because if you remember back at the beginning, we had 3 zeros, so fundamental theorem of algebra is being reinforced there.